In this video, we'll cover a few introductory comments about two different sections of our textbook. The first is section P1, and this is about solving equations. Now within that, we'll talk about a few different kinds: linear equations, and how to solve an example of that, and then also quadratic equations. And we'll define what a quadratic equation looks like, and then two methods for solving it using factoring and the quadratic formula. Then, in section P2, we're going to look at solving inequalities and how to represent inequalities. So we'll learn the difference between interval notation versus an algebraic inequality, and also the concept of bounded versus unbounded intervals. Okay, so our first example will be the solution of a linear equation. So in this example, we'll look at a simple linear equation: 3x plus 5 equals 29. Okay, and we want to solve this for x. So the first thing we should do is move the 5 over to the other side. And so 3x equals 24. And then divide both sides by 3. So x equals 8. And that's pretty straightforward. The next example is a little bit more complicated. We're going to look at a quadratic equation. Okay, so a quadratic is something of the form ax squared plus bx plus c. And this, so that's something that's quadratic, and if this is equal to 0, we call it a quadratic equation. So we're going to look at the specific example of x squared minus 9x and plus 8 equals 0. And we want to solve this by factoring. Now you may remember from high school there are lots of ways of solving quadratic equations, such as the quadratic formula, and we'll look at that in a minute. But factoring is another technique, and for simple quadratic equations like this, that might be good enough, and for this one it is. So in this case, we want to break up the quadratic into two pieces that look something like this: x plus or minus something and plus or minus something else. And what the somethings are we'll determine in a minute. Okay, so to figure those out, the first thing we're going to look at is this 8 here. And so we need two numbers to go here, here, and here that multiply to be 8, but they've also got to add to give us minus 9. So if we think about 8, how can you write 8? So let's just come over here and do some scratch work. 8 can be written as 2 times 4. It can also be written as 8 times 1. Okay, now 2 and 4 is 6, not 9, so that's not going to work. But 8 and 1, oops, 8 and 1 do equal 9. Okay, now we have negative 9 here, so that what means what we need instead is not 8 and 1, but negative 8 and negative 1. And then these, of course, negative 8 plus negative 1 equals negative 9. Okay, so those are the numbers we need. So it doesn't matter which order we put them in here because both of the first terms are identical, just x. So we'll do minus 8 here and minus 1 there. Okay, and now let's FOIL everything back out just to double check that we've multiplied correctly, or factored correctly. And so if we do that, the first term we get x squared, so that's x times x is x squared, that's the first. Then we need to do the outer, which is x times negative 1, so that's minus x. Inner is minus 8 times x is minus 8x. And last is minus 8 times minus 1, and that is, of course, plus 8. And then simplify and see what we get. X squared minus 9x plus 8. Okay, that's the same as what we had before, so we factored it correctly. Okay, now we can use our factorization to solve. So we have, I'll just copy it down. Two terms being multiplied to equal 0. The only way that can happen is if one term, or perhaps the other term, is 0. So this single equation splits into two cases. The first is if the first term is 0, and the second is if the second term is 0. Now each of these equations that we have, these are both linear. So we can solve them the exact same way that we solved this example over here. Just in this case, move the numbers to the other side. So x equals 8, or in the other case, x equals 1. Next, we'll look at the quadratic formula, which is another method for solving quadratic equations. It's very handy because it basically always works, but it can be a little bit computationally intensive. So you probably remember the quadratic formula from high school. So let's just start with the hypothesis. So let's remember from the last slide, a quadratic equation is something of this form. And the quadratic formula says that if you have this situation, then x equals negative b plus or minus the square root of b squared minus 4ac, and the whole thing is divided by 2a. And you may have learned even a song for this in high school, but I'll refrain from singing it for you for your sanity. Okay, so let's look at an example of how to use this. So the quadratic equation that we're going to work with is 25x squared minus 20x plus 3, and that equals 0. Okay, so in this situation, we have a is 25, b is negative 20, and don't forget the negative, and c is the 3. Okay, now we could try and factor this, but it's probably not going to be very easy to do so For one reason, the x squared has 25 in front of it, and that would complicate the sort of guess and check method that we did in the last slide with figuring out what numbers to put in our factorization. My rule of thumb for factoring is if I can't do it within 5 seconds, I don't bother, and I go straight to the quadratic formula, because chances are there's no easy factorization, but the quadratic formula is a formula, and basically will always work. Okay, the only problem that we're going to run into with this particular example is that we've got some big numbers here, 25 and 20. Now those by themselves aren't very big, but look what we're going to have to do in the quadratic formula. We need to compute, for example, 20 squared. 400, not too bad, but then we've also got this product over here and some subtraction to square root, and so the arithmetic may get a little bit complicated, but at least it's a formula and we should be able to plug through it. Okay, so per the quadratic formula, x equals negative b. Now b is already negative, so that'll make this positive 20, and don't forget that negative or else it won't work, plus or minus the square root of 20 squared minus 4 times a, which was 25, times c, which is 3, and that's all divided by 2a, which in this case is 50. Okay, now we need to do the arithmetic. So 20 plus or minus the square root of, well, 20 squared we said was 400, and that's pretty easy to do in your head. And then this product here, 4 times 25 is 100, times 3 is 300. So actually the arithmetic wasn't too bad. 50 in the denominator. And then 400 minus 300 is 100, so we have 20 plus or minus the square root of 100, all divided by 50. Okay, let's come over here. And, okay, square root of 100 is easy. It's just 10. So we have 20 plus or minus 10, all divided by 50, and that's still equal. Okay, so we have two possibilities here. One is the plus version, and the other is the minus version. So if I do the plus version, we have 20 plus 10 divided by 50. And then the minus version is 20 minus 10 divided by 50. And now we just need to work out which each one is. So here we have 20 plus 10 is 30 over 50 is 3 divided by 5, or 20 minus 10 is 10 over 50, and then we could of course just cancel those zeros, and so x equals 3/5 or 1/5. And that's it. Okay, so the second section that we'll look at today covers inequalities and how to work with them. What we're going to look at right now in the video is just how you write an inequality and sort of what they represent. So the first thing that we'll talk about are intervals. And an interval is written in the form a comma b. Also, we could have a comma b, and then there's two more, a comma b and a comma b. Okay, so these four possibilities, you may remember the difference between the round parenthesis and the square bracket, but if not, the round parenthesis just means the number is included. So for example, a comma b means all stuff bigger than, let's try spelling correctly, than A and less than B. Okay? And the way that I know it's bigger or less than is based on whether or not I have round parentheses or square brackets. Okay? So for example then, let's just look at this second one here. Okay, so we'll do A comma B is all stuff bigger than or equal to A, but still less than B. Okay, we don't want to have to write everything out in English like this, so we want to be able to write this statement in English in a more mathematical way. It'll be more compact and a little bit more precise. Okay, so the way we're going to do that is A comma B, all stuff bigger than X but less, or bigger than A but less than B. So let's just let X be something to represent the stuff. And in this case we want X to be bigger than A and less than B. And so this interval can be translated into an inequality. Similarly, A comma B can be translated into this interval, A less than or equal to X less than B. And that's a much nicer notation for it. Okay, so let's look at a specific example of this. If we have the interval 6 to 9, let's write this in inequality form like we did over here. So in this case, A is playing the role of 6, B is playing the role of 9, but we have one minor difference, namely we have a round parenthesis to the left and a square bracket to the right, so it won't be exactly like this previous example, but it'll be close. So this would be 6x 9, and then round parenthesis gets a less than, and square bracket gets a less than or equal. Okay, now one other thing about these intervals, all of these that I've written here, these are all bounded intervals. So what's an unbounded interval look like? Unbounded would be where one of these numbers, or possibly both, is an infinity. Okay, so for example, negative infinity to 2, or say negative 5 to infinity. Those are examples of unbounded intervals. Whenever you have the infinity or minus infinity, never use square brackets with it. Always round parentheses, because it's not possible for a number to equal infinity or minus infinity. Those aren't numbers. In the same way that 9, it's possible for a number to equal 9. Okay, so in this example, neither one of our endpoints are infinities, and so this is definitely a bounded interval. Okay, and let's look at one more example of something which is unbounded. So let's take the interval from 81 to infinity. Definitely unbounded. And just like before, we can write this. It's everything that's bigger than 81 but less than infinity. Now all numbers are less than infinity, so we don't need to actually write less than infinity. It's tacitly assumed. So all we need to say is everything that's bigger than 81. And that's all we need. So we could write this, and I'm going to write it in orange. Actually, orange won't show up very well. We'll write it in sort of an annoying pink. We could write less than infinity here, but that's not necessary because every x that you can think of is certainly less than infinity. So it's sort of redundant to say less than infinity. So all that's necessary is just 81 less than x.